All right. The first tutorial ask to import financial data and estimate risk and return and run regression in Python. Basically, we are practicing what we have learned in lecture 1 and lecture 2 here. So the first task is to extract historical daily share price of Apple with the ticker of AAPL from Yahoo Finance for the last 5 years. Just to remind you that any stock has got a ticker. For example, in case of Apple is AAPL, for Ford is, for example, F, for Tesla is TSLA, and we can connect our machine to Yahoo Finance, actually our Python to Yahoo Finance using a specific package that I will explain later, and use this ticker to download data directly from Yahoo Finance. So um, also task 2 asks to calculate daily return of Apple, interpret daily return of Apple for period of study using descriptive analysis, check mean, median mode, standard deviation, skewness, and kurtosis, and estimate the Sharpe ratio and compare it with the S&P 500, which is the index of the US market, and run a regression using market return as predictor and Apple return a dependent variable, interpret the results. So 6 tasks for the tutorial 1. So let's stick to the work. The first step, I'm going to open a new notebook and import my libraries. So the libraries I need here, number 1, pandas as PD. Number 2 is import numpy as np. Also, I need the library Yahoo Finance. So remember, Yahoo Finance is a library that you can, connect your actually or download data from Yahoo Finance directly. So import Y Finance as YF. This is the library I'm going to use here. And also we need library name date, time, and we put abbreviation DT for it. These 4 libraries, I'm going to import them. So as you see, all these 4 libraries already installed on my machine. That's why I don't receive any warning or error code. If this is the first time you are running these libraries or calling these libraries, it's better for you to, or you have to install these libraries by the command pip install, for example, Y Finance. So if I run this code, as you see here, and wait a minute. So I will receive this warning note. You are using PIP version. Our version is available. But more importantly, it says that requirement already satisfied, which means that Y Finance already is installed on my machine. That's why I don't need to rerun this code every time. So once you execute this code just for one time, this library is in your machine forever, so you don't need to rerun this code. That's why I don't use it. All right, so this is the libraries we need for this task. Okay. All right, the next step is to define the tickers. So I'm going to define the ticker. I need 2 tickers here, AAPL, which is for Apple, comma, GSPC. GSPC is for S&P 500, and Apple is for the company Apple. The start time is DT, date time. Remember, date time is a function in the library date time. So for the last 5 years, let's say, for example, 2018. Second of, for example, 20 February 2018, and end time would be DT, daytime 2023, second 20. All right. And then I want to define another array, call it prices, using the library Yahoo Finance. There's a function in this library, it's called download ticker. So download, I need a couple of items. Ticker, I already defined ticker. Remember, this is tickers, not tickers. If you say tickers, you need to put here tickers as well. Okay, so ticker, start, and an interval. Interval is one month or one day, depends on your work. Here I'm going to use daily. I think if you back to this, yeah, Yahoo Finance for the last 5 years, calculate daily return. So that's why I'm using daily, one day. So a start is the start date, end is the end date, and interval is daily. So let's see what will be the result. Prices. All right, so I see this is the data files downloaded. So this data file has got the adjusted closing price of Apple as well as GSPC, which is S&P 500, closing price, high, low, open, and volume of transaction. But what I need is just adjusted closing price. The only column we need for our interpretation is adjusted close price, which refers to the final close, the final closing, the final quote of each day, right? So if you run this one, so we see that we have got two columns now, Apple and GSBC, and the data or the variable refers to adjusted closing price of these two stocks for the last 5 years. And remember, this is daily quotes. So the price of these two stocks, Apple and S&P 500 index in the last 5 years daily. The next step is to calculate daily return of Apple. So I'm going to do for both of them. So I create another um, actually array, call it returns, which is equal to prices over prices, shift 1 minus 1. I explained for you what does it mean. It means, for example, what I'm doing here is I'm dividing price, for example, in 21st of February over price in the 20th of February. So that's why we say prices dot shift 1, which means that divide price today over price the day before, right? So shift 1 means the day before or lag of the price. Minus 1 to calculate the return, right? So if I double check, so now I have got the daily returns of Apple and S&P 500. Okay, and the first is none, which is not available because we don't have the code for the 19th of February. That's why it's not or non-available. All right. So to have or delete this none, there is one way we can say, okay, returns would be equal to returns dot drop NA, drop NA. So I would ask Python using the function drop NA to drop non-available or missing observations from my data set. So if I double check it, I would have something like this. So drop NA is not there anymore. Always you can see the first head, for example, the first 5 rows of your data file or the last 5 rows of your data file, or for example, a certain number of the heads in your data file as follows. All right. Next, interpret the daily return of Apple. So we have done it. You need to check mean, median, and standard deviation of this. We can do that easily. I will show you later on. Let's back to the, so I will just say returns. I have got array of returns. Returns describes a function, and you will see the mean, standard deviation, minimum, maximum, and different percentiles of return of Apple, daily Apple. So in other words, this number tells me in average, the return of Apple has been 0.0012 uh, per day in the last 5 years. Yeah, which is around 0.1%, which has been better than the market, as you see. Okay, so this is one thing you can do here. All right. The next one is that actually, what is the Sharpe ratio if you invest all your money in the stock of Apple in the last 5 years? So the Sharpe ratio is basically equal to the mean over standard deviation. The Sharpe ratio is the mean over standard deviation. So dividing mean over standard deviation gives you the answer, or the Sharpe ratio. Okay. So basically, again, you have got the returns as an array, right? Which includes the daily returns of Apple and GSBC or S&P 500. So you can use returns.mean, for example, to calculate, should be a spelling issue here, to calculate the mean or daily mean uh, of Apple and GSBC. As you see, this number is exactly same as this one here, and GSBC is the mean or average return of mean is here, right? For S&P 500 is here. And the same for returns std dot std. Just want to avoid another typo issue. So the function std calculates the standard deviation of Apple and GSBC. So Sharpe ratio, remember Sharpe ratio is equal to returns mean over returns std. And if we so Sharpe ratio would be for Apple is 0.6, 0.6, and for GSBC is 0.03. What does it mean? It means that if you have invested on Apple, per 1 unit risk, you earned 0.06, and for GSBC is 0.03. So per 1 unit of risk, you have had better return if you have invested on Apple. So this is the meaning of Sharpe ratio. All right. And the next one, compare the performance of Apple and market. As I said, using the Sharpe ratio, we can compare it, and we say that Apple has performed better compared to the market because the Sharpe ratio is higher. Then run a regression using market return as a predictor and Apple return as the dependent variable. So what we are trying here to calculate is basically the beta. We want to know what is the systematic risk of Apple, how the return of Apple is, or how far or how much or to what extent the return of Apple depends on the market, depends on the return of the market. All right. So for this purpose, we need to define again our X and Y and import the package which is required. The package that I need here is a stats models API. If you do not have this package, you need to install it first using pip install stats models. So I have already this package installed my PC, so I just import stats models .api as sm, and I'm going to define my x. X is what? Is our dependent variable, which is return in the array of returns refers to GSPC, GSPC, right? GSPC or the market. So here I defined the explanatory variable, okay? And y is equal to returns of APL. So this is the dependent variable. Define the dependent variable. Sorry for typos. Okay, so now what I'm going to do is to use the imported package, which is SM, to add constant to my X. So I have got, sorry, I'm going to define X as a cap. So if you see, let's run it. So I have got the arrays, including constant and GSPC as my X. And then I'm going to run regression. Regression is equal to SM dot OLS y X, the X cap, right? And fit. So the function of fit, OLS, basically I ask the Python to run this regression and give me the summary. So this is the summary of the regression. As you see here, I have got a significant model. 64% is the R-square, such as that 64% of variation of returns of Apple is explained by the variation of returns of market. And the constant at GSPC coefficient 1.23 here, which is significant in the level of 99%. And this is what this number is the beta, but this is a daily beta of Apple. Remember, because we use the daily quotes, all right? Daily quotes. If you back to the Yahoo Finance and check for AAPL as the ticker of Apple, go to the profile of Apple, you have got this number 1.28, but this beta is 5-year monthly. What we calculated is the 5-year daily. So one way to check if you want to have more accurate beta, which is usually practitioners prefer monthly beta. So I just changed this one frequency from 1 day to 1 month, and I can restart and run all of this kernel. Hopefully everything goes. And yeah, so I have got now 1.26. It should be, yeah, closer to this 1.27 almost, yeah, which is closer to the speed. And yeah, that's it. And as you see here, this is the return and standard deviation goes high because we are talking about monthly return of Apple, 3%, GSPC has been 1.8%, and the standard deviation of Apple is higher. Comparing these two, as you see, monthly, 36% for, I mean, per 1 unit or 1% risk of Apple, the earning has been 0.36, and for GSPC has been 0.35. Again, Apple performed better than GSPC. And this is uh, the solution for tutorial 1.